Welcome back to VQ Intel. In today's video, we're going to be looking at function transformations, specifically shifts. And if you want to follow along, down below in the description is the link to the companion worksheet. So the first thing to remember is that when we talk about shifts, what's going to happen is we're either taking a function and we're either adding or subtracting a number. Now, if we subtract a number outside, plus c or minus c, that's going to shift f of x up or down that many units. Now, oftentimes, most books or most teachers will just stop here, but I want to add an extra step, something else for you to think about. If I add plus c, what that means is I'm adding c to whatever the y values are for this graph. If I subtract c on the outside, then I'm subtracting c from the y values. Now here, if I'm adding or subtracting to x inside the function, that is before I apply the f rule, then it's going to do something totally different. Then what it's going to do is it's going to shift f of x left or right c units. Now notice that here when it's f of x plus c, I subtract c from the x values. And here when it's f of x minus c, I add c to the x values. And the thing that happens with function transformations is that whatever you do to x before applying the function, the effect is the opposite. So here it's plus c, we're actually going to subtract c from the x values. Here it's minus c, we're actually going to add c to the x values. So keep that in mind. When it's outside the function, we do what it says to the y values. When it's before we apply the function, it's the opposite to the x values. Now we're going to use this graph to help us graph some of these functions, and we're calling this graph g of x. So this first graph is g of x plus 2. So we're adding 2 before we apply the function. So according to our table, that means we're going to add, no, it's inside. We subtract 2 from the x values. And for my students, that's all I ask them to do, is just to say subtract 2 from the x values. You don't have to really worry much about shifting or shifting up, down, left, or right. You don't need to really articulate that. Now the thing to note is that the y values are going to stay the same. So this point right here at -6, -3, 1, 2, 3, 5, 6, down 3, it's going to move over 2 places to right here. And then this point was over here at -5, 2. This is going to go over 2 spaces. -3, 0 is going to go over 2 spaces. 0, 3 goes over 2 spaces. 2, 4 goes over 2. 4, 3 goes over 2. 6, 0, 3, 4, 5, 6. That goes over 2. 8, -2. That's over here. That's going to go over. 10, 0. That's right here. Now it gets moved over. And then 11, 1 is right here. So our graph, when we connect all these dots, is going to look something like that. So the whole thing just got shifted over 2 spaces to the left. Now the next one, g of x minus 1, here it's outside the function. That is, after we've applied the g function, then we subtract 1. So that means we're going to subtract 1 from y. So every y value, we're going to take 1 and subtract it. So that means 6, -3, -6, -3, 1, 2, 3, 4, 5, 6 was right here, but we're going to move it down 1 space. 5, -2 was right here, but we move it down. 3, 0, -3, 0 was here, but we're going to move it down 1. 0, 3 was right here, we move it down 1. 2, 4 was right here, move it down 1. 4, 3 goes down 1. 6, 0 goes down 1. -8, -2 goes down 1. 10, 0 goes down 1. And then 11, 1 is over here. So the whole graph got shifted down 1 space. And so here we're just changing the x value. And here we're just changing the y value. But on the next two, now we're actually going to do 2 things simultaneously. Here at x plus 3, this is before we apply the function. And so the effect is that this is going to subtract 3 from x And this one, plus 1, is after we apply the g function. So here we're going to add 1 to y. So -6, -3, 2, 3, -3. So down here, so we're going to subtract 3 from x, so it's going to go to the left 3 spaces, but we're going to go up 1. That's what we do when we add 1 to the y value. So over here, we go 1, 2, 3, and up 1. Then we have 3, 0. We go 1, 2, 3 over and up 1. 0, 3 was here. We go over 1, 2, 3 to the left and up 1. 2, 4. We go 1, 2, 3 over, up 1. 4, 3. So we go over 1, 2, 3 and up 1. 6. We go over 1, 2, 3, up 1. -8, 8, -2. We go over 1, 2, 3, up 1. 10, 0. So go 1, 2, 3, up 1. And then 11, 1 would be right here. We go over 1, 2, 3, up 1. So here is our graph. So the whole thing got moved 3 spaces to the left and got moved 1 space up. And then this one, here we're adding 5 before we apply the g function. So we subtract 5 from x, and here we subtract 4 from y. So that means every point is going to move to the left. That's what happens when we subtract from x, and every point is going to move down. So 1, 2, 3, 6, -3. So that means we go 1, 2, 3, 4, 5, down 1, 2, 3, 4, right there. So 1, 2, 3, 4, 5, down 2. So now we go over 1, 2, 3, 4, 5, 1, 4. All right. So every point just moves over 2, 5 and down 2, 3, 4. 0, 3, 1, 2, 3, 4, 5, 3, 4. Now as I make my marks, the final points you should mark boldly, because every time I drop my pen it makes a little mark and I need to remind myself, these aren't points. All right, so that was that point. So the next one is 2, 4. Right here, 1, 2, 3, 4, 5, down 4 like that. 4, 3, go over 5, down 4. 6, 0. 1, 2, 3, 4, 5, 1, 2, 3, 4. 8, -2, we go over 1, 2, 3, 4, 5, 1, 2, 3. Now what some people will choose to do is they will write out all the points ahead of time, and what they will do is they will write out what the new coordinates will be. So they'll look at a point like 11, 1 and say, okay, if I subtract 5, the x should be 6, and the y should be -3. So instead of starting at the first point and the final point, they'll just say, okay, this turns into 6, -3. So 1, 2, 5, 6, down 1, 2, 3. Just like that. And that's not wrong. For some people, they prefer to think that way. And that's okay. You can do that. So there is our graph. Shifted 5 spaces to the left and 4 spaces down. So on the next page, it says, given this function, state the parent function and how it is transformed. Now again, a parent function, like any function, is just something we do to a number. Now, we're talking about shifts. So all the shifts are basically adding and subtracting in this video. So here, if I look at this, here I'm subtracting 4. So if I ignore that, what's the parent function? X cubed. Okay, so what's the transformation? Well, I'm doing this, I'm subtracting 4 before I cube it. So that means I'm changing x. So that means I'm add 4 to x. Or we could say we shift x cubed 4 spaces to the right. All right. Next one. Here I have tangent of x plus 4. Now, you may not know what tangent of x is, and that's okay. You don't have to. All you have to be able to identify is I'm adding 4 to that. And as far as x is concerned, I apply tangent first, and then I'm adding 4. So what that means is that I'm going to add 4 to y, because I'm doing this after I apply the tangent function. So that means I shift tangent of x, whatever that is, up 4 spaces. Number 7, here I'm adding 3 and I'm subtracting 2. But the adding 3 I do before I take the cube root, and the minus 2 I do after I take the cube root. So the cube root of x is the parent function. The first transformation, when I add 3, that means I subtract 3 from x. And the minus 2 means I subtract 2 from y. So the overall change is that I shift the cube root of x 3 spaces left and 2 spaces down. Now over here I have subtracting 0.5 and I'm subtracting 3.2. Well, what's left? 10 to the x power. Now here I'm subtracting 5 before I raise 10 to that number. So that means I'm going to add 0.5 to x. And the minus 3.2 happens after I raise this number to the 10th power, 10 to that number. So I'm going to subtract 3.2 from y. So the overall effect is that I shift 10 to the x, 0.5 spaces to the right, and 3.2 spaces down. Now on the last page, here we've got these 4 functions, and what we want to do is we want to state the equation of the parent function and the equation of the transformed function. So the parent function is dotted, so you may be able to see that this is the dotted function. And so this is the absolute value of x. And so this up here is the transformed version of absolute value of x. Well, what happened? Well, I'm just going to use this vertex point as a reference. And so what happened? It just got moved 5 spaces up. We added 5 to the y value. So that means I'm going to add 5 after we take the absolute value. So this is absolute value of x plus 5. That's this equation. Number 10, here we've got this graph. This is x squared. And so what happened here? Well, let's look at this vertex versus this vertex. And it went from 0 to 4. This is very hard to see on the video, but you'll just have to take my word for it. Now that means we added 4 to the x value. So that means I'm going to subtract 4 before I square it. So this is quantity x minus 4 squared. Number 11. Here we're back to absolute value of x. And so from here to here, now we moved in 2 ways. Here we moved 2 spaces to the right, and we moved 3 spaces down. So we added 2 to x, and we subtracted 3 from the y. So I do the opposite before I take the absolute value on the inside, and then I subtract 3 on the outside. And the last one, here I've got x squared again. Now over here, what happened? It moved over 1 space to the left, and it moved up 2 spaces on the y. So that means I'm subtracting 1 from the x, so that means we're going to show the opposite. And then I added 2 to the y. So this is quantity x plus 1 squared plus 2. Thanks for watching. If you want to support the channel, links to support are all down in the description below. Thanks for watching, and remember, the best way to understand something is to do it.